Hello algebra students, we're going to take a look at section 10.3, solving problems involving inequalities. Can you solve word problems using inequalities? So we need to think about that 5-step process. I'd love for you to pause the video and put your 5 steps in. Alright, so hopefully you got the 5 steps to read the problem. Sometimes you've got to read it more than once. Set up for your variables. Write an equation, solve the equation, and then when it's a word problem, you write a sentence answer. So when we're looking at the inequality, that's sometimes easier. We can see what symbol we're supposed to be using. But when we've got a word problem, we have to do some interpreting. So we're going to take a look at that, and we want to think through what the relation symbols would be for some situations. If we want at least 15 pairs of shoes, think about what relation symbol that would be. Enter it on Edpuzzle, and then we'll check. You should have put greater than or equal to. If I want at least 15 pairs of shoes, I want 15 pairs of shoes or something more than that. How about at most 15 pairs of shoes? That would be less than or equal to. If I have at most 15 pairs of shoes, it means I have 15 or I have less than that. If I see the phrase no less than 15 pairs of shoes, that should be greater than or equal to. I want 15 pairs of shoes or more. I don't want less, so greater than or equal to. How about no more than 15 pairs of shoes? That should be less than or equal to. I want 15 pairs, but no more than that, meaning I could have less than that or equal to that, but no more. Is less than 15 pairs of shoes. That is just the is less than symbol. How about is more than 15 pairs of shoes? So is more than is just the greater than symbol. So for example 1, we come across a fairly familiar word problem with consecutive integers. So we find the pair of odd integers whose sum is at most. So this is at most is kind of the new part of that, is at most 200. So we read through the problem, we want to do our setup. If we've got our first consecutive odd, then that would be our x, and our second consecutive odd, we know, should be x plus 2. We want to build our equation, so we've got the sum being at most 200, so we'll start with the sum, x plus 2. At most means it could be that or less than that, can't be more than that, so it has to be less than or equal to 200. We want to solve our inequality, so we're going to simplify that left-hand side. Subtracting 2 from both sides. Dividing by a positive does not change the relation symbol. So we get x is less than or equal to 99. Now we do want to write our solution set. So we've got that x such that x is less than or equal to 99. And then of course we want to make sure we find the pair. So if the first integer is 99, and then the second integer is 99 plus 2 is 101. So the highest pair, whose sum is at most 200, is 99 and 101. All right, so let's take a look at the next one. This should say example 2, so we'll fix that. And now we're looking for a pair of even integers whose sum is at most 200. Now, of course, our defining our variables is going to be the same. We're just looking at consecutive evens. So our first integer is x. Our second consecutive even would be x plus 2. And we're looking for the sum of those to be at most 200. So our equation starts out the same. And of course, when we solve that, that is going to be the same. But then as we're looking, we want to plug in, we need to pick an x that is less than or equal to 99, but we're looking for an even value. So we don't want to plug in the 99 this time. We've got to go less to our even number. It's got to be less than 99, so it can't be 100. So our first integer would be 98, and our next integer would be 2 higher than that, which would be 102. So we've got to make some decisions that make sense for the problem. And then, of course, we write our sentence answer. So if we're looking for even integers, then the pair would be 98 and 102. So we're looking at our next example. Again, I'm just going to edit that in, example 3. And this time we've got a rectangular problem. So we've got the width of a rectangular computer screen is 20 centimeters less than twice the width. The perimeter is at least 53 centimeters. We want to find the minimum dimensions in centimeters of the screen if each dimension is an integer. So reading through, we want to then do our setup, and we've got the width being based on twice the length. So I'm going to have my length be the variable, and the width is 20 centimeters, then twice the length. So twice the length, and I need 20 centimeters less. Watch that you're doing that minus 20 behind. When we've got less than something, we have to have the something first and take what it's less behind that. So 2x minus 20. Now we're deciding that we need at least 53 centimeters. So we've got a perimeter. We think about perimeter. Perimeter is for a rectangle is twice the length plus twice the width. So I'm going to write that as an equation. 2 times the length plus 2 times the width. And that has to be at least 53 centimeters. And at least we want it to be 53 or greater. So greater than or equal to 53. And then we're going to solve that inequality. And when we solve that inequality, we get x is greater than or equal to 15.5. But then we need to go back up to the problem. And so looking back up here, that each answer is an integer. So we need an integer that is, we want the minimum integer that is greater than or equal to 15.5. And so that would give me 16 centimeters for the length, and 2x minus 20, so 2 times 16 minus 20 for the width, and that would give me 12 centimeters for the width. And then we want to write our sentence answer. So the minimum dimensions are 16 centimeters by 12 centimeters. So this one's a your turn, so I'd like for you to pause the video and don't forget to do your 5 steps: read, set up, write your equation, solve, and then give me a sentence answer. Then you can restart and check. So hopefully you got your x is greater than or equal to 18, and that would make the dimensions of the rectangle 18 centimeters and 12 centimeters. Make sure if you didn't get that, you're bringing any questions you have into your algebra teacher. And let's take a look at the next example. All right, so this one is also your turn. So again, I'd love for you to pause the video, see if you can solve it yourself and check in. If you're stuck, you can go ahead and continue. I will walk you through this one. So Sonia is a waitress. She earns $200 a week plus a 15% tip on the cost of each meal she serves. what must be the total cost of the meal she serves in order for her to earn at least $425 each week? So she earns $200 a week plus a 15% tip on the cost of each meal, and we want her to earn at least $425 a week. So I'm going to have M stand for the cost of a meal. And she earns that $200 a week, so she gets that no matter what. And then she also gets a 15% tip. So we have to think about, okay, on those meals, that would be 0.15 times the cost of a meal. And we want her to earn at least $425 a week. At least is greater than or equal to, so greater than or equal to $425. And we're solving, so we're going to subtract 200 from both sides. We at 0.15m greater than or equal to 225. We're dividing by 0.5 or 15%. And we get that our cost of a meal has to be greater than or equal to $15. So of course this is during the week, so it would be on average, she's would have to have the meal price be greater than or equal to $15. So we're dividing by 15% there, and so we get M, or the cost of the meals, has to be greater than or equal to $1,500. Now, it doesn't mean a meal itself costs $1,500, but it means that she would have to serve, meals worth that throughout the week. So the meals would need to add up to $1,500. Remember to take all your questions into your algebra teacher.